Okay, so what we're trying to do on here is figure out which expressions, if any, are equivalent. So when they're equivalent, it means that they come out exactly the same. They're going to simplify to the same thing. So even though they don't look the same, could they simplify to the same thing? That's what we're trying to figure out. In the same way that 2 plus 3 and 5 don't look the same, but they mean the same thing. So in this first question, I noticed that inside the parentheses are some like terms. I could do distributive property first, or I could combine them first. It's up to me, since the like terms are in the parentheses. If they weren't, then we do distributive property first. Since they are, I'll combine them first. So my multiply is easier. So I have some B's and some more B's. And then I have some numbers. Oops. Make that a little nicer. Some constants and some more constants. So I still have this negative 2/3. Then I still have the parentheses. I haven't done distributive property. Negative 12 plus 9 is negative 3. And then negative 6 plus negative 18 would be negative 24. So then I'm going to do distributive property. So negative 2/3 times negative 3 gives me a positive 2b. And then negative 2/3 times negative 24 gives me a positive 16. And that's as far as I can go, because b's and 16 can't go together. They're not like terms. I don't know what b is, so I'm good. So now I got to check the other expression. This one, I'm just going to start with distributive property. So 2 times b would be 2b. And 2 times 8 would be 16. So which expressions are equivalent? Both of these are. So this one just said, are they equivalent to each other? Because there was just 2. And I could say, yes, because they both came out to 2b plus 16. In number 10, I want to figure out if any of these are equivalent to each other. So the first one really just has me start with distributive property, right? So I can do 4 times x, which is 4x, and 4 times minus 3, which is negative 12. When I do the middle one, this time the like terms aren't in the parentheses, so I'm going to start with distributive property. And one big thing you got to know here is that even when we do this, when the distributive property doesn't start all the way on the left, I still keep the sign to the left of it. So don't just distribute the 2, it's a negative 2. So I have 6x still left that we didn't touch. Then negative 2 times x would be negative 2x, excuse me. And negative 2 times negative 3 would be a positive 6, so plus 6. Then I can combine my like terms. 6x and negative 2x. 6 plus negative 2 would be a positive 4. And then I still have plus 6. So these two are definitely not equivalent. They both have the 4x, but because the constant's not the same, they're not the same. Let's check my third one. So again, I'm going to start with distributive property because the like terms aren't inside the parentheses. And so I still have my x that's outside. Then 3 times x would be 3x. And then 3 times negative 2 would be negative 6. And then I still add also another minus 6 from the problem. Then I got some like terms. So x plus 3x would be 4x. And then I have minus 6 and another minus 6. So negative 6 and negative 6 is negative 12. Again, use your calculator if you don't know that. So which expressions, if any, are equivalent? This one is not, right? Because it was plus 6. But these two were both 4x minus 12. So I could say that, let's see, we'll kind of put that it was 4 times x minus 3 and x plus 3 times the quantity x minus 2 minus 6. Those were equivalent to each other. So last but not least, we've got the last problem here. Again, I'm trying to see if any are equivalent. So for number 11, I'm going to start with what's in the parentheses, which I noticed there's some like terms. So I'll do those first. So then I have the problem 1/3 times the quantity 9x plus 18 and then plus 2x. Then I'm going to do my distributive property. So 1/3 times 9 is 3 and 1/3 times 18 is 6. And then I'm not going to do it times the 2x because it's not in parentheses, so I still have plus 2x. 3x plus 2x, combining my like terms, is 6x, and then I have plus 6. So there's my first one. Let's see if it's equivalent to any of the other two. In the middle, again, I'm going to start with distributive property. And so I still have 7x. I still have plus 14. Then negative 2 times x would be negative 2x. And negative 2 times 4 would be negative 8. And so then I can combine my like terms. I got 7x and minus 2x, which is 5x. And then I have 14 and minus 8, so it would be plus 6. So this one is really close to this one. They have the same constant, but they don't have the same number of x's in the problem. And so this one is not, oops, no, I made a mistake in my first one there, right? Let's go back and fix it. I said it 3x plus 2x was 6x, but actually it's really 5x. Oops, I multiplied instead of added. So these two definitely have the same answer. Let's check out the third one and see if it also does. So again, I'll start with my distributive property. So I still have, see, I'm going to write it a little below just because I'm running out of space here. Still have the x, still have minus 3, and then 7 times x is plus 7x, and 7 times 3 is plus 21, and then I still have minus 3x minus 12. So like terms, we got an x, we got a plus 7x, we got a minus 3x. So 1 plus 7 is 8 plus negative 3 is 5. 5x. Looks good to match these other ones. Then negative 3 plus 21 plus negative 12 would also be positive 6. So figure out which ones are equivalent, if any. The answer to this problem is all. are equivalent.